Welcome to EDUC 3662 and 5662 students. My name's David Hewitt. I'm going to be taking you through the lectures over these next 9 weeks, and I'm going to be also offering the tutorials on a Wednesday afternoon and a Thursday afternoon to both groups. This unit's all about measurement and geometry, and the first part of the lectures will be dedicated to measurement and the second part to geometry. And today in particular, we're going to be looking at the measurement of length. But before we start, can I just acknowledge and pay my respects to the Aboriginal and Torres Strait Islander people, the traditional owners of Australia. And I'd like to acknowledge elders past and present, as well as those emerging leaders of tomorrow. And I thank them all for their wisdom and guidance as we share and collaborate together. Before I go any further, I'd just like to take time to pause and acknowledge a very close personal friend, my best friend, Dr. Derek Hurrell, and a professional colleague over the 40 years since we met. And Derek, those people who had met him at Notre Dame, sadly passed away suddenly on the 4th of November last year. And as such, I've been very grateful to be asked just to step into these 2 units to help out the university, and also to acknowledge and continue the lovely work that Derek has done over the past, I think, 13 years since he worked at Notre Dame. He was a great lecturer, a great friend, a great educator, a great thinker, and he's sorely missed by us all. My name's David Hewitt. I've had a fairly extensive background in education, as you'll see here. And I kind of like to divide my career into 3 parts. Probably the most important part's the one on the left-hand side as the Freo ardent Freo supporter, and that's my smile because in 2023 we've just won the grand final, and that's a photo from the future. But to go back into the past, the first third of my career was pretty much in the government system as a teacher and then a principal all around the state in various primary schools. That's in the part of my career when I first met Derek. The second part of my career has been characterised by work in the independent sector, where I was a principal and I worked at the Association of Independent Schools, but I also worked overseas as a consultant and looking at education reform projects in Malaysia and the United Arab Emirates, and I've also worked in Bali and a little bit in Bangladesh as well. During that time, I also worked at ECU doing some lecturing, and I also wrote the primary maths course at UWA at that time. The third part of my career has been back in the government system, but also then working at our West Australian Primary Principals Association in various roles, looking at supporting principals in their schools and deputies in their schools, but also had a bit of a well-being focus and making sure that people were in a really positive mental state, which is not always the case as you'd appreciate in education. And also then last year I ran a tutorial group, 3 tutorial groups at Murdoch University. I've done lots of work with Paul Swan. I think I walk in Paul's shadow, and he's just an amazing educator, and I've been lucky also to have worked with Paul over these years. So that's me. At the moment, it's so new, I don't have a university staff number or an email address, so if you'd like to contact me, that's the email that will get the quickest response, david@edn.net.au. And if you're in my tutorial classes, I'll give you my mobile phone as well. However, having said that, I'm pretty sure within the next week I'll have a university email address, and we'll be able to communicate as would be expected through Blackboard. However, hopefully I'm not just going to talk to you through a lecture system. I'm hopefully looking forward to meeting you face-to-face over the period of this term/semester. Again, we're just going to be looking at this Maths 3, the measurement and geometry for this unit, and it's really up to you. You need to take responsibility of what you're going to be looking at and doing in terms of the unit itself. We'll help you and guide you, of course, but ultimately it's your responsibility to make sure that you're across the lecture and the tutorial schedules, and also, of course, your requirements for assessment and the requirement for Landtite as it comes up, and I'll be talking a little bit more about those things as the term progresses. However, for now, let's just move on and let's start with this idea of measurement and looking at the idea of attributes. And what do you think an attribute of measurement is? Because we've got attributes of measurement, and then we've got attributes of measurements as well. And as the little hint sense there, length is one part of measurement that we're going to be looking at, and particularly in terms of the work we're going to be doing today. So here we go. I know you've had a chance to think about these things, but of course, typically we look at measurement and we measure things such as length, area, volume, capacity, mass, time, and temperature. And those two in the middle, volume and capacity, often get us confused, and we often interchange them. So I'm going to ask you to pay particular attention to make sure that you're really clear in terms of what your understanding of volume and capacity, and what are the similarities. In fact, what are the differences? Why do we use these two terms? And can they be used interchangeably or not? There's a little bit of homework for you to follow up. But are there other elements of measurement we could look at? Well, angle is possibly one that we could be thinking about. However, in the Australian curriculum, it sits in the geometric reasoning part of that curriculum rather than in measurement. But of course, it has a very close relationship with measurement because we have a quantification. We can divide those angles into degrees, and we can measure the size of an angle, and we can classify that according to the number of degrees. And then we have some language about acute angles, obtuse angles, right angles, all sorts of things based on the number of degrees in the angle itself. So be careful, but angles, while we think it is an element of measurement, it's actually in the geometric reasoning part. And of course, money is that another thing that we can measure. We can measure wealth, we can measure poverty quite easily, we can quantify those things. And we think that money could possibly sit in an area of measurement, but it's clearly not at the moment. There's got elements of number, we can quantify it. But what do you think the elements of measurement might be within money itself? And does it sit within a measurement capacity, or is it somewhere else? In fact, does it sit out on its own in terms of the Australian curriculum? Some questions for you to think about. Now, Booker, Bond, Sparrow and Swan, they talked about this idea of, unfortunately, many measurement lessons are basically just number lessons given in a measurement context. And of course, we don't want to do this. We want to make sure that it's quite clear that when we're doing a measurement activity in a classroom, it's clearly the focus is on the measurement, and the number, the quantifying of it, is just a byproduct, if you like. It's a way that we can standardize our responses and have some understandings around it. But the most important thing is it's a measurement lesson. We're using the element of measurement, and we're looking at the attributes of that particular element at that particular time. How do we do that? Then for comparison, we use that idea of quantifying it. But remember, it's not a number lesson, it's a measurement lesson in its own rightful place. So News Ed Maths, I'm sorry the video is covering up the rest of that URL at the moment, but if you're looking for some really good resources to supplement your classroom teaching, the NZ Maths site is a really good one. And here the quotes are, why do we teach measurement? And of course, under NZ Maths, they're saying that it's important providing links between those different strands of mathematics. And for example, it provides a rich and meaningful context for the use of number skills and spatial concepts. And of course, what we want to do whenever we're working with mathematics, or at least as far as possible in the primary school, is we want to link that understanding to real life concepts and real life activities, and measurement allows us to do that. So rather than just some random numbers sitting there somewhere that the kids don't relate to, we can use measurement to give them a real life context for using those numbers. And then the second dot point, again, it provides those links between maths and other subjects. Measuring skills, especially estimating, have an important place in many games and sports, as you'd understand. Who's faster, longer, all those sorts of things at sports. But of course, in science, measurement and mathematics plays a huge part, as well as in artistic endeavors and musical experiences. Music ranks fairly highly within the skills within that. So measurement and mathematics itself goes across and is multidisciplinary, if you like. Now, another reason it's important part of the curriculum is not just the mathematical, but the pedagogical things. So it's an effective way to engage diverse student needs and their interests. Some students are more motivated to learn about measurement than other mathematical strands. Why do you think that's the case? Why do you think children enjoy learning more about measurement than perhaps sitting rote learning a number table, for example? Well, as the last sentence says, they often see the usefulness of this task as it relates to them personally. And of course, again, using that real life context, we can use mathematics to make these real life contexts to the children and their learning, and they can actually see that clearly in measurement. Think about cooking alone. Look at all the measurement activities that we need in cooking. We've got time, we've got quantities, volumes, capacities, all sorts of things, weights, all those little measurement elements that we can incorporate just in that one lesson. And of course, rather than just sitting in the seat, this is getting the kids up and active and doing things. So make sure that you create these lessons in a pedagogical sense that are really engaging. Actually, it applies to all mathematics, not just measurement, number, space, everything that you can think of. Make it relevant and interesting to the kids. So why do we teach measurement? Well, of course, it allows us to quantify the world, and by quantifying it, we can make sense of that. We can compare things. We can talk about taller or shorter, heavier or lighter, wider or narrower, longer or shorter in terms of time. So we can compare using these elements and attributes of measurement. We can look at things that change over a period of time. Think of those science classes where you're growing a bean seed and the kids are going out daily measuring the growth of the seed from the seed once it germinates into its stem, etc. So over a period of time, we can quantify that and make comparisons. We look at things like rates of growth and compare those against other plants, if you like. And of course, there's the need to measure and then quantify. So once we've decided on the measure that we're going to use, then we can work out the quantities of that measure that we're going to use to compare and relate to other things. So it allows us to quantify the world. Excuse me. And when we quantify the world, or actually when we make sense of the world, that's when the kids are being numerate. Just like literacy isn't just on its own reading or just on its own spelling or grammar, it's the combination of those. It's the ability for children to make sense of the world, the word, and interpret it into their world, if you like. That's literacy. Well, numeracy is the same thing. It's not just about number. It's about making sense of the world using all those things that are at their disposal within a mathematical context: number, space, geometry, measurement, whatever it might be, algebra, etc. When the kids are being numerate, you know that they are thinking mathematically and being mathematicians, if you like. So measurement, what is it? It's the idea of comparison, because if I said something was 1 kilometre long, I mean, that's a really interesting concept. You might have an idea in your head how far a kilometre is from here to there. How close will you be? Well, there's another element we're going to be talking about in terms of estimations. But of course, measurement allows us to compare things. And as we said earlier, bigger, taller, shorter, lighter, heavier, all those different attributes or comparisons that we can make for kids to make sense of their world. All measurement is approximate. We can get right down to nanomillimeters or whatever it is. But of course, at the end of the day, it's up to us to try to be as exact as we can, but we can't be precise without the tools that we need. And in a classroom, it's much more difficult. And actually, it's not as relevant. I mean, does it really matter if I'm 1.865.32 centimeters high or 1.86.531 centimeters high? At the end of the day, it's not really relevant. I'm only about 180, so I'm telling fibs already, but I look very tall in the video, I know. So all measurement is approximate. And the last thing is estimation is important, but otherwise the concentration is on the numbers. And one of the things I'd like you to consider when you're working with your children in the classrooms is always give them the opportunity to estimate first and then measure. We want them to be really confident to be able to estimate quantities, lengths, etc., volumes before they actually have to measure. Because in real life, how often do we need to be precise in our measurements? If you're cooking, you're using it by taste, or half a teaspoon or a tablespoon or a cupful. We don't need to have those exact amounts, but we need to know roughly what those quantities are and what those ratios are to make the cake turn out. But at the end of the day, is it down to the exact number of grams or mils? No, of course not. The cake will still turn out delicious. So what is it that students are required to in measurement? Well, first of all, they have to understand the ways that units are used to quantify amounts, and they have to choose the units which they're going to need for their required level of accuracy. So if we're going to be measuring something that's 3 kilometers long, are we going to be measuring it using millimeters, centimeters, decimeters, meters, or kilometres themselves. So what is it the unit we're going to need to use to be able to quantify that amount? We need to be able to calculate indirectly, first of all, using those relationships of measurement that we already know exists, for example, easily between metres and centimetres and millimetres. We need to identify and understand the nature and the different physical attributes that can be measured. So when we're looking at length, what is it, the attributes that we're actually measuring, and what's the quantity or what's the tool that we're going to use to measure length as opposed to weight? How does that differ? What's the attributes that we're going to be looking at when we're measuring something, the weight of something? And lastly, we make judgments about the measurements for a range of purposes. And again, this is around putting it back into a real life context for the kids so that they can have a purpose, a real life purpose for undertaking measurements, and then make those informed judgments. And then once they've got informed judgments, that can then lead to them being creative and thinking a little bit more externally around it all. And again, here we go, it's estimation that's more important, otherwise the concentration is just on the numbers. And we don't want the kids to do that. We want them to be efficient at estimating. Just like we want to know that, 6 sevens are around about 40, for example, not 60. And eventually they'll work out that 6 sevens are 42. But it's all right to know the numeracy of it is that knowing roughly what the amount's going to be before we actually have to calculate the exact quantity, and then we can compare the two. And unfortunately, research indicates that children may be leaving school with a limited estimation-related understanding or competence, which might actually not only hinder their mathematical growth, but also inhibit them being numerate in the wider community. So again, the idea of making sure the students estimate carefully or estimate first before they measure is really important to develop them into true and proper mathematicians. Continue on. Some children misinterpret the purpose of estimation and can be done by the teacher applying too much emphasis on being correct or those who are closest. So, I mean, if you're going to celebrate the child who estimates the most closest to the measurement itself and celebrate that, then you're denying those other kids the opportunity to create their own ideas of how big or small or long or tall or whatever it might be is. Yes, we want them to be close, but at the end of the day, within a millimetre doesn't matter, within a centimetre doesn't matter, within 10 mils doesn't matter, within a kilogram doesn't matter. I mean, what's the purpose of the measurement? But we want the kids to be able to estimate and be confident with that rather than necessarily be correct with that. And as it says that last two sentences, a good way to alleviate it is to celebrate and reward all estimations that are reasonable rather than those that are correct. I remember clearly back in when I first started teaching my year fours back at Adam Road in Bunbury and getting them to estimate. Well, they loved estimating, but for example, if we were estimating the width of the classroom, funnily enough, their measurement that they made was 6.5 metres, and then the estimate that they made was 6.5 metres, and I know which one came first. So I needed to work with those kids to be really confident to their estimate first. 6 metres is a good approximation of 6.5 or 7 or 6.25 if they had the understanding in decimals. It doesn't need to be spot on. The more iterations of estimation that the kids can do, the closer they will get to it. But, you need to make the call as to what's the reasonableness of the estimation and celebrate that. I think we've done estimation to death. Now, this is up to you to have a look at, but in the SCARSA document in the Mathscope and sequence, the Peter 6, you'll see that this slide shows using units of measurement and how it works from pre-primary right across to year 6. And if you read across that top line, you'll see that in the pre-primary, excuse me, they're using direct and indirect comparisons at the top. And then in year 3, measure, order and compare using metric units of length, familiar metric units. Whereas up to there's no need for them to be using necessarily the formal metric units. So all those early childhood years, we're using non-standard units and informal units to get the idea of what measurement looks like before we start to introduce those formal standardized units of measure. Let's get going. And again, you'll see just what I'm saying. If you look at the pre-primary to year 3 scope across there, using direct and indirect, and then in year 3 using familiar metric units of length. And then again, going up to year 6, where they're starting to convert all that into decimal representations, because our metric system allows to do that, not just in number, of course, but when we're using metric system to measure. So you can see the scope of that. It's really important, for example, if you're teaching year 4, that we look at what we're we're doing in measurement and using units of measurement in year 4, but have a really thorough understanding of what happens in P1, 2, and 3, because not every child's going to come to you ready for that learning, and you need to understand and be able to revise or review or even teach those earlier concepts, because until they understand those really familiar in a familiar context, then really they won't be able to understand using scaled instruments and what that means in year 4. And of course the other side of it is you'll have some kids that'll eat that up, and so you need to know, okay, what's taking them forward. So even though they're teaching year 4, don't bore them batless, take them into what the next thing is, and if it's using appropriate measurements, or it might be using decimal comparisons. But just because you teach year 4, that's not the only content that you teach. Look at everything on either side of that so that you can be the best teacher for your students possible. So let's go back to measurement, and we're talking now about standard units of measurement. Now, what is it? Well, it's an agreed measure. So pretty much wherever you go in the world, if we're talking about meters, we're talking about length here. A meter in Australia is exactly the same as a meter in China, in Indonesia, in India, in UK, in South America, wherever. There's an agreed standard of exactly how long a meter is. And of course, because we understand how long a meter is, we understand how long a centimeter is, how long a millimeter is, how long a decimeter is, how long a kilometer is. It's an agreed measure. It's a standard unit of measurement. When is it useful? Well, we use it when we record data for later use, and we can measure something now for 5 meters and go back a little bit later, a month later, and say, oh, how long was that that piece of string? Oh, that's right, it was 5 meters. What is it now? It can be transported, so we can talk about the idea of a meter in, length of material, and it's the same as a meter in a road length, if you like. So it's something that we can use in multiple contexts, but only, of course, when we're using it as the attribute of length, or the measurement of the attribute of length. It's something that can be communicated. So no matter what I say, but if I say to you, I'm 2 meters tall, then I'm lying, but you get an idea that I'm actually quite tall, and that's fairly standard. So 2 meters when I'm standing up or lying down, you've got a pretty good idea of what that might look like. So you can communicate those concepts. And then of course it's used for calculation. So if we're going to use a calculation for area, and we're going to using meters for that, then we know the length of both sides, and we can calculate the area of a rectangular piece of work, or land, or whatever it might be. So using standard units of measurement are really handy. And back in the old days, because I am really old, you can probably tell from my face on the video, we used to have this thing called the imperial system, and it was all based on this idea of 1 foot in the bottom left-hand corner, and that length was, it looks pretty shoddy, but that was how long 1 foot was. And if you look to the right of it, there's 6 inches and 3 inches, obviously 6 inches. Well, if you remember, 1 foot was 12 inches. So 6 inches was a half of that, and 3 inches was a quarter of it. And then if you look above that in the middle, there's 2 feet, so that's twice 1 foot, and then a yard. So suddenly we changed the language from feet to yards, and a yard was 3 feet. So back in my day, we could measure something as 3 yards, 2 feet, and 6 inches. And then we had to calculate what that meant. And think how easy it is today if we're just saying something is 2.5 meters long. We use our metric system. It's standard with our number system. We don't have to do these internal conversions. So back in the day, the imperial system was a standard unit of measurement, still used, I think, in the UK in some places, but thank heavens in Australia we moved in 1966 to the metric system. Now, still using standard units of measurement, we also need to be really careful about the language that we use when we're talking to children about these things. So, pretty simple statement, which is bigger? Now, if I asked you that question, think about the attribute that you're going to measure or compare when you're looking at those 2 bottles of water. Okay, I'm assuming most people would be thinking, when I look really closely, the sparkling Coles water on the left-hand side is 1.25 litres, whereas the Evian is 1,250 millilitres. How do I convert? Which one is bigger? Well, those of you who are familiar with this sort of thing would know that the volume of both of those is exactly the same. 1.25 litres is exactly the same as 1,250 millilitres, and they convert between the two. However, that's in our adult head, and we have already we're naturally inclined to look at that, and when we see that question bigger, we automatically go to volume or capacity. Children, though, when you ask which is bigger, they will probably say, oh, I think the one with the blue lid is bigger. Now, what attribute of measurement do you think they're looking at to make that comparison? Here we are, where the teacher's in the classroom and we're asking which is bigger, looking at the volume and capacity of these two bottles, how much is inside, how much do they hold, what's their capacity when they're full. But kids are looking at length, or in this case, height. And you'll find a lot of children say which one's bigger, because that's the concept they've been brought up with, the concept of height, the linear measure. And they'll say, oh, I think the one on the right is taller, it's bigger because it's taller. Some children might be looking at the width of the bottles, which is bigger, and they might say actually the bottle on the left-hand side is bigger because we can see it's wider than the bottle on the right. So again, as teachers, we've got to be really careful with the language that we use and be quite direct and explicit in what it is we're asking when we ask in this context which one is bigger. So when we talk about these things, the big ideas of measurement come to fore, and first of all, we identify the attribute to be measured. So in the example just previously, those two bottles, the attribute that we're going to be looking at will be capacity. How much do they hold? Once we've got idea that what the attribute is, then we're going to be able to compare those two bottles, or in fact we've got 3 or 4, and then we can order them. We can order them from the ones that hold the least to the one that holds the most. These next 2 dot points are really important. Very early on, and you saw that up to year 3, we don't start to use the metric system in our units of measurement. So we start with what we call non-standard units. And we want the kids to be really comfortable using non-standard units to measure before we go on to the idea of standard units, which in this case could be related to the metric system. And I'll talk about non-standard in a little while. So there's a difference between non-standard units and standard units. Non-standard units might be, how many hand spans wide is your desk? Or how many feet placed one in front of the other does it take to cross the room? So we're using a non-standard unit, and the unit then becomes, oh, there's 26 of my hand spans is the desk wide. I can now compare that for the teacher's desk to my desk and find out which is wider or which is narrower. Or my foot. Okay, it takes 39 of my feet to go across the room, but it takes 42 of my friend's feet. Now, why does that take? Why does he take more feet measurements than me? And we can start to compare the idea of his feet are probably smaller than mine, so he's going to take a lot more to go across the room. So there's lots of rich learning that we can do just using non-standard units. And then, of course, when we come to standard units, that's what we're most familiar with. And then we can apply the measurement that we find on the measurement that we've got of the attribute that we've taken. So what do we do? First of all, what's the attribute that we're going to be measuring in length? Then here's the fun part. We can actually start to manipulate that. So using non-standard and standard units, once we've identified the attribute, we can play with it. We can talk about it, we can explore it, and we can make comparisons. So I've got a base of knowledge, and now I can start to explore. Given the knowledge that I've got, I can take that knowledge a little bit further and explore and have fun with my friends around. Okay, the desk is this wide, but how many desks does it take if I was going to put them end to end to cover the room? How many desks would it take if I was going to cover the oval from one goalpost to the other? So once we start to get some data, we can manipulate it, talk about it, explore it, and then make those comparisons. And basically engage kids and have some fun. Now, comparing and ordering, we've also got the language. So here's the language of mathematics coming into it, the literacy of mathematics, if you like. And we've got this comparative language that we can use in our literacy classes, and we can also use those in those literacy lessons. But it's also language that we need to talk and to teach about in the classroom. So for us, tall, taller, tallest, heavier, heavier, heaviest, and slow, slower, slowest. They're the language. That's the language of comparison that we can use to support the kids. But of course, it's specific to the attribute of measurement that we're looking at. So when we're measuring something in length, we're not going to be talking about heavy, heavier, heaviest, or slow, slower, slowest. There's language that sits particular to the attribute that we're measuring. But again, this needs to be taught. The kids don't pick this up automatically. And now we can introduce the big idea about transitivity, and it's based on comparison. So, for example, if you've got three containers, A, B, and C, as you can see below, A's got grape juice, B is orange juice, and C is lemon juice. We've got three different capacities. We can say straight away that A is greater than B, it's greater than C. We can also say, therefore, that then A is greater than C. So we can start to make these comparisons beyond two pairs of things into three and more. Now, of course, here's one that's quite fun. Looks like it's from Lord. Let me be your ruler, and then of course the play on the words ruler, and Lord is using herself as a non-standard unit to try to measure a box. Maybe if the box was a little bit longer, using Lord as a non-standard unit would be a good way to do it, but difficult to use a half a Lord to be a ruler in this case. But again, let the kids have fun and play with it. And so what are some of these big ideas around measurement? And again, I think without doing this to death, the idea is that before standard units introduced, non-standard units should be developed naturally. And then we have a look at the idea that units are absolute. They've been chosen to, not absolute, sorry, they're chosen for convenience. So measuring a classroom, as the example says here, a student's pace would be more appropriate than a handspan. But let the students find that out. Let them work out that measuring the width or the length of a classroom using a handspan or the length of a hand perhaps isn't quite as efficient as using something bigger, which is a step, but then is a step going to be the same each time. You don't have to give that understanding to the kids. Let them discover that themselves so that they can start to know that if they're going to be measuring, I don't know, the width of the room, the most appropriate measurement for that might be meters and parts of meters rather than trying to measure the room using millimeters. Again, let the kids develop that understanding from their own practice, if you like. So yes, while a student's pace would be more appropriate, don't deny them that opportunity to have a little bit of fun too and measure the width of the classroom using just a handspan. The second point is during the activity, the unit used mustn't change. So you can't change a handspan to a pace, to a foot, to a stride, to your friend's fingernails or whatever. The idea of measurement is using a standard or a non-standard unit. So the unit is the thing that's accountable, or that's countable, I'm sorry. And so it needs to be consistent in whatever measurement so that we can use that sense of comparison, etc. So as it's put here, it's not appropriate to change from paces to book lengths. And then the third point is comparisons are performed by taking all measurements in the same unit. So the largest number represents the greatest amount of the attribute being measured. So then we're starting to look at the quantities, and it's easy for the kids to see as the quantity is bigger, so the measurement must be bigger, if you like. So those 3 points are really important. Use non-standard units, but try to get the kids to develop their understanding of what non-standard unit is most appropriate in what context. The second one is the unit can't change. So once you've identified the unit, then it must be consistent. No gaps, no overlaps is what we say as well, and we'll pick that up in the tutorials. And of course, the last one is the comparisons must be using the same unit. So I can't compare the width of the classroom using handspans to the length of the classroom using the students' paces, because we're using two different sets of standard units, or in this case, non-standard units, so we can't compare. Three really important ideas, but again, we can use that concept and those three understandings whether you're using non-standard units or standard units. And then in our some more understandings. The larger the unit, the smaller number obtained, and again, vice versa. And let the children find this out for themselves. You don't need to teach this. This can be done by the children's own experience. So again, let them experiment with hand spans across the classroom versus foot lengths versus paces, and then have the discussion about what they think is most appropriate. And again, we're using smaller measures where it's less than one pace. What are we going to use? Let the children come up naturally with the ideas and let them experiment. Second dot point, a wide variety of experiences in the use of non-standard units provides opportunities for estimating, choosing those appropriate units, and then looking for tolerance of errors in judging the degree of accuracy. So again, those three little things are really important when we're establishing these base understandings of measurement, using non-standard units, which then apply when we come into standard units. Really important. Now, when we go into standard units, of course, we're using metric units, and again, the exceptions, like unfortunately, angle degrees, temperature degrees, and different degrees between angles and temperatures, of course, and times, where we go back into some weird system where we've got 60 seconds in a minute, and is that right? Yeah, 60 minutes in an hour, and 24 hours a day, etc., etc. So thank heavens that we use metric units for most of our things. And then what we do within those metric units, the experiences that we get the children become familiar with the quantities, the language that's associated, and we need to teach that language. We can't assume that the children understand that. And then the language that's associated for writing and symbols, because of course maths has a variety of different literacies, not just the numbers, but there's the graphic system and the symbolic language of mathematics as well that we need to make sure the kids learn, and we need to perhaps teach a little bit more directly, if not explicitly. Then using the correct measuring devices for the attribute that we're going to be measured. Again, this whole idea of making estimations in real life situations and getting the kids to be very comfortable making an estimation, regardless of how close it is. We want it to be close and reasonable is the word, but it doesn't have to be exact. And then looking eventually at mastering those equivalences between units, such as, 100 centimeters is 1 meter, 1,000 meters is a kilometer, etc., etc. So it's a slow build before we even get to that last dot point. And here's a time for celebrating. Interestingly enough, it's my wife's birthday, 20th of May, but now we can all celebrate because it's World Metrology Day. Now, it's not Meteorology Day, but if you have a look at the little slide here, in 1875, 17 nations agreed on how long a meter was. And now that's the basis for an international agreement. Of course, even now going into space, all those agreements based on how long a meter is goes backwards in terms of millimeters, centimeters, decimeters, nanometers, etc., and then right out into kilometers and light years, etc., all based around that 20th of May. So when it comes up, let's have a party in our maths tutes. Some more big ideas is when we apply it, and we only apply this thing when we're comfortably and efficiently measuring using appropriate standard units. It's in bold. We want to really shout that out and make sure that you understand why that's important. And again, that's all underpinned by using non-standard units. The use of measurement formula is a powerful tool for generalization, but we don't use formulas until right towards the end. We use experiences and experiential activities to develop before we even worry about looking at formula and formulae. And then we apply it to other situations and extend the sense of length, which in this case, if we link length to area, of course, we need to know the length of the sides. And can we do that in meters? If it's a field that's 20 meters by 30 meters, do we know how to multiply by multiples of 10? What if it's a field that's 26.32 meters by 19.79? Are we able to multiply decimals successfully, or can we just go to a calculator? Do the children understand what they're doing when they're multiplying decimals as related to measurement, as opposed to just multiplying decimals in the maths classroom in the number sense? So again, we don't do that until later on in the kids' experience. Why is it important? Nice little couple of things. You can read these, but basically I'll just go through the data. This plane in the top picture, Air Canada, ran out of fuel. because the ground crew was confused over the units they were using during refueling and had been calculated in pounds instead of kilograms, which is pretty interesting because I think there's I can't remember what the conversion now between pounds and kilograms, 2.2 pounds to a kilogram or something. So they badly underestimated the amount of fuel the plane needed, and thankfully the crew was able to glide the aircraft in and not crash land simply because they didn't know the unit that they were using. And then the NASA example here, I'll read this to you, it's quite lovely. In 1998, at a cost of over 300 million back in 1998, what would it be worth today? Contact was lost on the 23rd of September 1999, not quite 12 months later, about 9 months later, as it attempted to land on Mars. What happened is a subcontract incorrectly specified the thruster performance using non-metric units, leading to an incorrect trajectory and the loss of the spacecraft. So again, be careful what the units that you're using are, because that 300 million in 1998 could well be a billion today, just lost. Not only that, but the time and the lead up to replace that would be hugely expensive as well. So are units of measurement important? Definitely. I think those two examples say why. So when we go down this pathway now of developing formal measurement, again, don't introduce it until comparison and estimation skills have been well experienced. Use direct comparison using matching but no number. So we use the language of direct comparison: taller, shorter, wider, thinner, heavier, lighter, all those comparison words. And don't forget, we have this is long, this is longer, this is longest. So we're not compared to, although when we directly compare, we usually directly compare two things, but pairs of things, which then line up into three or more things, and we can compare them as a seriation rather than just as a pair of things. But we match, but we don't need the numbers. We can use the attribute that we're measuring of length, taller, shorter, etc. for direct comparison. We use non-standard units. I think I've made that point really carefully before we go to standard units, and then once standard units, then we can go to formal. We use that in connection with our number skills, and we wouldn't be measuring in decimals until we actually have aligned that in the class and the kids understand what decimal measurement or decimal numbers mean in terms of the place value system itself and why it relates to, measurement in terms of 1.32 meters is the same as 1 meter and 32 centimeters. The kids need the understanding of decimals in a number sense before they can connect it with their full measurement. And then, of course, I don't know that I've said this before, or maybe I have. At each stage, estimation not should be encouraged, but I think should be insisted upon, so the kids get really comfortable with estimating and getting to a reasonable approximation before they calculate or actually measure. So what does the curriculum say about length in pre-primary foundation years? We use those ideas of direct and indirect comparison to decide which is longer and explain in everyday language, and we'll unpack direct and indirect a little bit more in our tutes. Year one, they measure and compare the lengths of pairs of objects using informal units. Uniform informal units, beg your pardon. Year two, those keywords compare and order and informal units. Year three, we start to measure, order and compare using familiar metric units. Now, we saw that earlier when I showed you the snapshots of the curriculum. Year four, we're starting to use the idea of scaled instruments. Now, don't get really worried about what that means. Scaled instrument can just be a ruler or a beaker that's marked in milliliters or litres, whatever. So it's an idea of a scaled, a regular scaled implement that we can then measure with. Year five, using appropriate units for measurement of length. So do we measure something, the length of the table in kilometres? Do we measure the length of the table in millimetres? Or do we measure the length of the table in metres? Whatever's the most appropriate unit. Year six, as we said, connect those decimal representations to the metric system. So 1.32 is a decimal. What does that mean when we're talking about 1.32 metres? Well, it means 1 metre and 32 centimetres, or 1 metre, 3 decimeters, and 2 centimetres. Yes, centimetres. I've got to get it right too. And then we can convert between those common metric lengths, and then we can solve problems. So it gets quite complex at year six, takes it out of the concrete into the abstract sense. So when we're looking at length, what are the following questions? We're looking at these things of comparison. So indirect and direct comparison, which is longer without quantities. How long is it? We start to use quantities and units for that, and then standard and non-standard units, and then how much longer is it than the other one using standard and non-standard units. Good news. Whew, we're nearly at the end. No, it's not just the good news. Now, so if students deeply understand measurement ideas about one kind of attribute, they can then transfer this knowledge to other attributes. So if we spend a lot of time looking at length and understanding what length is, then that understanding can be more easily translated into attributes of area or capacity or weight, because they're developing the same sort of understanding. I think the research around learning languages is similar. If the students learn a second language, by the time to come learn a third language, it's more easy than it was learning the second one. So it's perhaps some ideas around that as well. Well, okay, it's been a big week. That's a long time for you to sit, and I hope that you've been able to take a lot of that in. Just like in the classroom, we shouldn't be talking at kids, and I really shouldn't be talking at you in a lecture sense, but the beauty is in the tutorial you'll have a chance to now have a play and apply this learning in the classroom so that you can put a little bit more contextual understanding on the theory that I've provided today. Thanks for your attention and involvement. Have a great week, and I look forward to those of you who I'll be seeing in my tutorials. Thanks again. Bye.